So first of all, what is this?
It's a question mark.
The question mark. And when do we write the question mark?
Whenever we have a question, obviously.
So right now, do you have any question in your mind? Like what are we doing over here?
No questions asked. I think there's a sign here for no questions asked.
No, there must be some question.
Oh,
Okay. So what can you see in front of you?
there is a air pumper, 3 balloons, and a marker.
Okay. What do you think we are going to do with these balloons? What are we supposed to do with them?
I think you have to pump them up there.
Should we do it?
Yes.
Okay, let's see. Okay.
Just don't do it.
You want to pump it?
Yes, but I'm not going to do it until it...
Alright.
Should I do it until it pops?
No. I'll tell you when to stop. Okay. Keep doing it.
It keeps on going behind here.
Alright. Okay, what is happening?
It's coming up there.
Okay. This is a nice amount of air inside. How do you know that we are filling it with air? It's filled with air.
Because it's like, at first it was like one of these balloons, and now it's and now it's blown up like it. It's become fat.
Okay. How has it become fat? What is inside it?
It's air, or
What has air done to it?
it's made it little more chubby.
Okay. Inflated it.
Yes.
More.
And what do you say?
Expand.
Expand. I mean, if there was stuff inside it, if it started to try to expand it, it'll just pop out of nowhere. It won't have enough. It'll just, even if it goes slightly, it'll pop the rubber.
Okay, okay. But that is when there's a lot of air inside and the air particles are, it's pushing the...
It's like this.
Exactly, it's pushing the walls of the balloons further and further and expanding it.
It's expanding like this balloon.
Yes, so that means that the air has taken the space inside the balloon, right? And what do you think the air is it a gas or what?
A gas.
Okay, a gas. And what do you think? Anything that occupies space inside that has mass as well? Does it have weight as well?
No, it doesn't.
Since gases are really light sometimes, but they do have slight weight. It's the amount of gas you put inside, because the gas, it just takes up the space that is provided to it. Otherwise, we've actually caught air inside the balloon. Otherwise, do you think what do we have in our surrounding? What are we breathing in?
Air. Oxygen.
Right. Oxygen from
and also, oxygen is one of a part of air, if you're watching this.
Yes, right, exactly. So anything that occupies space and has a mass is called what?
Matter.
Matter, right. So
and I'm not saying the matter that matters.
Yes.
Remember
right.
that?
So it's called what?
Matter. Double T-E-R. Matter.
Very good. Exactly. It's called matter, and matter occupies what?
Space, mass, and volume.
And yes, mass and
volume.
It has volume. When do we talk about volume, by the way? When are we talking about what? Most of the time. Discussed, and we already know. What do we know from the videos that we've seen?
The matter is has space, mass, and volume.
Okay,
and they have 3 states: solid, liquid, gas.
All right.
And this is the main state.
Okay. So does all the states have the same kind of characteristics?
solid we can hold, liquid just goes off our hands, and gases, well, it's like liquid, but it just is like when I move my hand, I don't feel it just gets out of my hand.
Yes, it just the particle
liquid just stays there for a little while, like when you
but they flow like that, right? But the gases, all the particles are just
like
flying here and there. Exactly. So do you want to know about their properties? What are their difference?
Yes.
What can you see in front of you?
A glass of water, two empty glasses, and a ball. And obviously, you know this. I already talked about this.
All right. What do you think we can do with this to find the difference?
Well, I'm going to pour some water inside it.
Okay.
I hope I just don't drop some.
All right. Carefully. Okay. I think this much is enough.
And should I fill the other container?
Let's put the solid ball in it. What happened?
It's not going in.
And what about the water?
It went in. It's fit in.
And it has taken what?
Space.
Yes, and the shape of the glass, right?
Yes.
And what about the ball?
It's just stuck there. Let me get it out. I think we might have same every time.
Why? Why do you think so?
Because look at this.
Okay. Maybe it is made up of some particles that are, quite strongly joined to each other.
Yes.
And they don't want anybody to, disturb them or make them, change their place, right?
Yes.
And the liquids, I think the particles are, sliding. That is why the water has taken the shape of the container, right?
Yes. But we can, if we had it, we should have.
What did you conclude from this experiment?
Liquid takes up space, but solids don't.
Solids don't take up space?
They do take up space, but they
don't change the shape,
yes,
right? But liquids
do take the shape. They're like,
yes, exactly.
like our hands are solid.
Yes.
But
Like
humans are solid.
Exactly. But do you think Mama has the same characteristics as you?
Nope.
We both are different?
For some things.
Yes. So that is how it works for the states of matter, like liquids and solids and gases. They all have different properties, right?
Yes.
Yes.
And I also figured out something.
All right. Okay. If we take liquid over here, can you name some liquids?
Well, I can. Ink.
Okay.
Ink.
Yes.
And this water here.
Yes.
That is spilled all over the table.
Yes.
Thank God it's not gone.
Okay.
And what else? Juice. Coke. What else can I name?
Any thick liquid can you think of?
Slime.
Okay.
Slime is like a little it flows really slow, but it is like a liquid kind of thing.
Yes.
But it's not like a solid. Solid just stays in one shape. It doesn't. It just keeps on going down. It doesn't keep on one shape.
Okay. And what about ketchup that you love?
Yeah, ketchup. Everyone loves ketchup. Everyone.
And honey.
Honey.
And oil.
Oil. But doesn't some oils are also like a little smooth liquid?
Yes. So do you think you just you just said that, I just figured out you said that earlier just now, that slime moves slower, right?
Yes.
So that means that all different liquids have their different properties. Exactly, like water will flow fastest, oil will be a little
slower,
ketchup will be a little
more slower,
slime will be a little,
not little, more slower.
Exactly. So their speed is like
like water is going this,
hmm.
oil going this, ketchup going
what did we learn today? That everything
around us is matter. And I'm not saying the matter that really matters. Please.
and matter has
Mass, space, volume.
and matter exists
And also I can say VSM.
Okay.
For volume, space, and matter.
Okay, and matter exists in
3 states.
Okay, Mike, can let's discuss about the states of matter you just told. Like, are all the states always in the same state, or can they be changed? Yes, ideas.
We can boil ice cube and see what happens to it.
Oh yes, let's do it. Okay.
Next lick.
Okay, Maya. Now what we are going to do?
We are going to put an ice cube in this pan.
All right, you can put that ice cube.
I'm
Okay.
too scared.
All right. Now see what is happening to it. Can you explain? With the temperature increasing, what is happening?
It is melting.
Yes.
I can see some smoke too.
Yeah.
Oh my gosh!
And what about this steam?
That is water vapor.
And when do they come in? Like how are they made?
But when the water is boiling at the precise temperature,
Yes.
it starts to boil and it turns into
Okay.
a gas. It turns into water vapor. That is a gas.
Okay, if you try to put a lid on top of it, let's see what happens.
Is it cool?
Yes, it's cool. It's a cold lid.
Then let's see.
Let's see. Oh,
Why-
what happened here?
The water, when the water went on the
Lid.
lid, it turned back into the water vapor went on the lid. It went back into water.
Yes. And what is this process called?
Condensation.
Oh yes. So like this. This process is interchangeable. Like we've turned the solid to liquid first and the liquid to gas, and the gas has been turned back to liquid. So which process is that?
Condensation.
Oh yes, that is a condensation. But Meyer, we are like interchange. The process is
A reversible change.
yes, it's a reversible chain. And if we can you give me some example of an irreversible change?
Well, we can do an experiment for that.
Yes, we can do an experiment, but can you give me an example?
Well,
What do you do? What do you eat in the breakfast?
I eat cereal. I eat egg.
Okay, when the egg is in the liquid state, and then when you fry it, what happens?
It turns into a solid.
Yes. So can you turn the egg back to the liquid state?
No.
So what is that process called?
Irreversible change.
Yes. So that is how it's different. Can you give me quickly give me an example of another irreversible change?
When let me see. Let me explain this. How can I explain this? When a toy is broken, sometimes it cannot be fixed at all.
Yes, exactly. And when a potato is cut into fries and you fry them in oil, so can you reverse it back to the solid potato again?
And oh no!
Okay, and when you make a jelly, can you reverse the change back when after the jelly is being frozen?
Oh no!
Very good, excellent. You got the point then. I want to do an experiment and let's see how an irreversible reaction takes place. Okay, which one do you want to do?
I want to burn a piece of paper.
And see what happens.
Yes.
Okay,
Correct.
all right.
Okay, so this is the piece of paper we will burn. It's burning. can you get this? This is what is happening to the flammable. Turned into dust. Somehow it won't be turned back. It cannot be turned back.
Alright, so it's burned completely.
Yes.
So can you turn the ashes back to the paper?
Nope.
No. So
it's
that
still
means
green.
that it is
Irreversible.
irreversible. Okay, Maya, what are you making?
I'm making a diagram of what the solids and liquids do.